All right, so we're going to pick up again with graphs of rational functions. And so in the warm-up here we've got, it says use t-tables to show what happens to the graph of f of x as x goes to positive or negative infinity. So basically all we're asking you guys to do is just start plugging in numbers that get bigger and bigger and bigger and show what happens as x gets bigger and bigger and bigger. So our notation that we used yesterday was the notation down at the bottom left here. As x goes to positive infinity, where does y go to? As x goes to negative infinity, where does y go to? So that's what we're going to use the t-table for. So if I start plugging in numbers for f of x, I'm going to do the first one slowly and then I'm going to fill in the t-tables. But if I plug in 1 for x, I would have 1 over 1 minus 5 and then take away 3. Now in this case I'm just going to do decimals because it's easier to see what's happening if we go to decimals. So if we were to pop that in our calculator, we would get negative 3.25. Negative 3.25. If we plug in 5, 5 minus 5 is going to give me 0 in the bottom of this fraction, which automatically means I am undefined. If I plug in 10, I get negative 2.8. Negative 2.8. If I plug in 100, I get negative 2. We got some decimals, 9894. Whoops. 2.9894 decimal right there. If we plug in 500, we get negative 2.9948. So you can see the numbers. I'm not getting much a lot bigger or a lot smaller, but I am getting closer and closer. Here's the last one, negative 2.9989. And so you can see that I'm getting closer and closer to negative 3 here. All right? So we would say that as x goes to positive infinity, because you can see down the left side of this table, x is getting bigger and bigger, so x is getting closer and closer to positive infinity, y goes to or gets closer to negative 3. Okay? And then the next side of the table, we would just start simply plugging in negative numbers for x. So if we do that, the first one turns out to be negative 3.166 repeating. The next one turns out to be negative 3.1. So, whoops, not sure what happened there. Negative 3. Oh, there we go. The next one turns out to be negative 10. I'm going to have to do this one. Negative 10 minus 5. Hang on a second, I don't have a number for this one. Alright, so if I do negative 10, I'm going to end up with negative 3.0666. If we do negative 100, I'm going to end up at negative 3.0095. So you can see that these numbers are getting closer and closer and closer, and then negative 3.00198. And finally at negative 1,000, negative 3.00099. So these numbers are also getting closer and closer to negative 3. So we would say that as x, so I'm looking at the left side of this table here, okay, I'll change colors here just to emphasize this. As x gets closer and closer to negative infinity, the y values on the right side are getting closer and closer to negative 3. So when that happens, we say that we have a horizontal asymptote. So we're going to use HA, horizontal asymptote at y equals negative 3. So I can go ahead and graph that right away. So I'll put a dashed line here at negative 3. All right? And then it says, what is the vertical asymptote for f of x? The vertical asymptote is basically what makes my denominator what makes my fraction undefined. What value of the denominator would make it 0? So if you go back and look at your fraction, the minus 3 has nothing to do with the fraction. It's the x minus 5. If I plug in 5, we already showed in the table that it's undefined. That's my vertical asymptote. X equals positive 5. So we're going to go ahead and graph that guy. All right. And then it says to graph f of x. Now, some of the things that we find when we graph is y-intercepts, x-intercepts, and things like that. So I'm going to go for a y-intercept first. So I'm going to have to do that up over here, y-intercept. So I'm just going to plug in 0 for x. So this is going to be f of 0 equals, and then I would do 1 over 0 minus 5 minus 3, and we're going to end up with f of 0 equal to, this is negative 1/5 minus 3, which is negative 3 1/5. I didn't go to decimals on that because it's not too bad. So, but if you look at where that's placed on the graph, it's just below our horizontal asymptote right there. And we don't have to be perfect about it by any means. And then my x-intercepts, all right, we'll do those guys over here, x-intercept. We're going to plug in 0 for y. We're going to get 1 over x minus 5 minus 3. We're going to go ahead and add 3 to both sides. So that's going to give us 3 equals 1 over x minus 5. I'm going to put the 3 over 1, and I'm going to cross multiply here. 1 times 1 is 1. 3 times x minus 5 is 3x minus 15. We'll go ahead and add 15 to both sides. So now we have 16 equal to 3x. And if we divide out the 3, we get 16/3, which is equal to 5 1/3, which is my x-intercept. So my x-intercept actually turns out to be right over here, right on the right side of my vertical asymptote. Now, if you know what these graphs look like, you can go ahead and draw them right now. If you remember what you were graphing last night and what we talked about, the only other option you would have is to maybe plug in a number or two and create a t-table. So I'm going to do that. I'm just going to do 2 more values for my t-table. I'm going to do an x and a y here. And I'm just going to pick a number that's close to the asymptote. So to the left side, I'm going to pick 4. And to the right side, I'm going to pick, I think I'll go 7 on the right side. So if I plug in 4 to the equation, I'm going to end up with negative 4. If I plug in 7 to the equation, I'm going to end up at negative 2.5. All right, so let's see what we get there. So 4 and negative 4 gets me another point right there. And 7 and negative 2.5 puts me right there. So now you can see where the curve's going to come down the vertical asymptote and roll around right over your horizontal asymptote, just like that. All right? And that's graphed. We got some key points on there, and we're good to go. Let's check out the next part. All right? So it says the line y equals k, so k can be any real number, decimal, whole number, positive, negative, is a horizontal asymptote of a function f of x if, as x goes to negative infinity, so as x gets really small, my y's get closer and closer or go to the value of k, whatever that k might be, or as x goes to positive infinity, y goes to k. All right, and then we just showed that in our warm-up up above. Okay. All right. The vertical asymptote, we're going to focus more on the denominator for this guy. Excuse me. We're going to focus more on the denominator for this guy, but the line x equals h is a vertical asymptote of your of your rational function if, as x gets closer and closer to h. Okay, so remember our vertical asymptote on the last one was 5. So as x gets closer and closer to the value of your vertical asymptote from the positive side, that's what that little plus means there, your y values will go to positive or negative infinity. So if you look at my graph up here, just like we got done seeing here, so from the positive side, that means from the right side, look at where my graph is going. My graph is going to positive infinity. And from the left side, from the negative side, my graph is going to negative infinity. And it doesn't mean that all negative sides will go to negative infinity and all positive sides will go to positive infinity. That's just what our graph is doing right now. So as x goes to the value of h, so think about it as the as the vertical asymptote up top. As x gets closer and closer to 5 from the negative side, y gets closer and closer to either positive or negative infinity. All right? Okay. So how do we use asymptotes to graph? Okay, now if you know some shifts, it makes it a little bit easier, but we're also going to talk about vertical and horizontal asymptotes as well. So here's my form here. You guys are going to recognize the h and the k here. So my general form is f of x equals a over either x plus or minus h. So that's your left-right shift. Okay, so this is going to shift your vertical asymptote left or right. And the plus k here is going to shift your horizontal asymptote up, down. All right? And so that's the parent function that you see next to that. And this would have a horizontal asymptote here and a vertical asymptote right down here. And that's what we would be talking about shifting. If the function is a squared function with a positive a value on top, we get both curves going up like this. We saw one of these yesterday. And again, the h is your left-right shift, the k is your up-down shift. So if we can, we're going to first apply vertical or horizontal shifts. We're going to find our x and y intercepts, and then we'll do an additional point or two as needed. All right? I'm going to have to pause for now and come back to you guys later. Okay, so we're going to sketch the graph of h of x equals 1 over x minus 2 plus 1. We're going to try and transform it from the parent function 1 over x. Now again, if you remember, the parent function 1 over x just looks like this. All right? It's a curve on the upper right, curve on the lower left. If you don't remember that, that's okay, because we're going to plant some other points on here too. So my vertical asymptote always comes from my denominator. X minus 2 cannot equal 0. Okay? So if I set this guy equal to 0 and I solve it, I get x equals 2. That is my vertical asymptote. So right now, I'm going to graph a vertical asymptote at 2. If I remember my function shifts, this bottom part is the x minus h in my generic form. So it's telling me shift the graph 2 units to the right from this parent function on the right side. Horizontal asymptote. All right? The horizontal asymptote on this guy is y equals 1. All right? And that comes from this plus 1 right over here. All of other the graphs, if that plus 1 wasn't there, if that was gone, the horizontal asymptote would be y equals 0. But because that plus 1 there, we're now saying shift that graph up 1 unit. All right? So my horizontal asymptote's going to go right here. All right. And then I'm just going to find another couple other points. I know that I should have curves either in the upper right, lower left, or upper left, lower right. So I'm going to start with the y-intercept because that one's usually easier here. So h of 0 equals 1 over 0 minus 2 plus 1. If I do the math here, that's negative 1/2 plus 1, which equals positive 1/2. So that tells me that I have a y-intercept at 0, 1/2. So I'm going to graph that. I'm going to find my x-intercept next. So we'll do 0 for y equals 1 over x minus 2 plus 1. I'm going to subtract 1 from both sides. Negative 1 equals 1 over x minus 2. I'm going to put the negative 1 over 1 so that I can cross multiply here. 1 times 1 is 1. Negative 1 times x equals negative x. Negative 1 times negative 2 equals positive 2. Subtract 2 on both sides. I get negative 1 equals negative x. Divide both sides by negative 1. And I get x equals positive 1. That means I have an x-intercept at 1, 0. So look at that. So I can kind of start to visualize the curve in this lower section right here. All right? And so now I just need a couple of points on the right-hand side, so I would probably just do a little t-chart here, an x and a y, and I would probably just pick 3 and 4 as my two values. If I plug in 3 I end up at 2. All right, and you can do the math on your own. If I plug in 4, I end up at 1 1/2. So right here, and boom, 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 right around the corner, just like that. Domain and range on this guy. The domain is x in the set of reals. This graph goes all the way to the left, all the way to the right, but it jumps over x equals 2 because that's my asymptote. So x cannot equal 2. The range on this guy, y in the set of reals, or negative infinity to positive infinity, but y does never equal positive 1. All right, that's my horizontal asymptote. Let's take a look at this next one here. All right, so starting off with vertical asymptote, I look at my denominator here. I want to know what makes x plus 4 equal to 0. If I subtract 4 on both sides, I get x equals negative 4. There's my vertical asymptote. Right away, I'm going to draw. Horizontal asymptote. Look at this. I've got a negative 5 right here. So I know that my horizontal asymptote is going to go down to y equals negative 5. It's way down there this time. Wow. All right, here we go. X and y intercepts. Y-intercept. P of 0 equals 2 over 0 plus 4 minus 5. This is equal to 1/2. Take away 5, which equals negative 4.5. So I have the point 0, negative 4.5 as my y-intercept. We're way down here. All right, this is going to be an interesting one. X-intercept, plugging in 0 for y, we get 0 equals 2 over x plus 4 minus 5. I'm going to add 5 to both sides. Why am I adding the 5 to both sides? Because now I can cross multiply the two sides very easily. I put the 5 over 1, I multiply 1 times 2, that's 2. I set it equal to the product of the other side. 5 times x is 5x, 5 times 4 is 20, and now we need to solve this. So we'll subtract 20. That's going to give me negative 18 equals 5x. If you divide by 5, you get negative 18 fifths. Now, negative 18 fifths is actually 5 goes into 18. I know this answer is going to be negative 3 times with 3 left over. So negative 3 3/5 is equal to, oops, here we go, equal to x. All right, so my x-intercept is negative 3 3/5, which is right about here. So we can already see that this graph is going to curve down this way. And we don't really need any more points. We just want to know about where the curve is at. Now, I have a feeling that I'm going to run into problems on the other side here, because if let's try plugging in negative 5. Let's do a t-table, x and y. If I do negative 5 in my t-table, all right, if I plug in negative 5, I'm going to get negative 7. So negative 5. Ooh, yeah, I'm like way down here. I'm way off the grid. Let me try negative 6. Let's see what we get. Negative 6 is going to give me negative 6. All right, so that one's a little bit better. But you can see again where the curve's going to come underneath the horizontal asymptote and then down next to the vertical asymptote. And that one is done. Domain here, x in the set of reals. However, we're jumping over the number negative 4. So x cannot equal negative 4. Range, y in the set of reals. But we're going to jump over negative 5, so y cannot equal negative 5. All right? Do we have any left? Oh yeah, it looks like we got one more. Okay, so here we go. Squared function. All right. So vertical asymptote. Now, again, I look at the denominator and I ask myself, what's going to make that denominator equal to 0? Technically, that denominator is nothing more than x minus 3 times another x minus 3. They're both the same factor. So I set one of them equal to 0, x minus 3 equal to 0, and I get x equals 3 for my vertical asymptote. So we're going to go ahead and draw that. Horizontal asymptote, right away I'm looking for this guy right out here, y equals -2. Alright, so here we go, -2. Alright, y-intercept, h of 0 equals 1 over 0 minus 3 squared minus 2. Ooh, this one's going to get a little interesting here. -3 squared is 9, so this is 1/9 minus 2. Now you're going to have to do some fraction work here, but 2 is really, if I put 2 over 1 and I multiply it by 9 over 9, it becomes 18 over 2. And then 1 take away 18 is -17. Oops, excuse me, this is over 9. -17 over 9, which is equal to -1 and 8/9. So I have a y-intercept at 0, -1, and 8/9, just like that. And that's going to be right down in this area here. Okay, so now we need to find the x-intercept, so I'm going to plug in 0 over here, and we're going to do 1 over x minus 3 squared minus 2. I'm going to add 2 again, because I want to be able to cross multiply if I can, so I'm going to have 2 equals 1 over x minus 3 raised to the second power. I'll put my 2 over 1, and again, all I'm going to do is cross multiply here. So I've got 1 times 1 is 1. Now, I'm not actually going to multiply out the other side here. I'm just going to write out 2 times x minus 3 squared. Now, why am I not multiplying this out? Because at this point, I can go ahead and divide by 2 on both sides. I can get rid of that 2 right there. So I end up with 1/2 equals x minus 3 squared. Why do I not want to multiply out the x minus 3 squared? Because I can square root both sides of that. So if I square root this and I square root this, and as long as I remember my plus and my minus here, let's see what we get here. Alright, so the square root of 1/2, okay, this is going to get ugly here for a minute. I might have to stop and break out a calculator here, but the square root of the right side is just x minus 3. The square root of 1/2 is the square root of 1, which is 1, over the square root of 2. So this is plus and minus, okay? And let's see, now I would add 3 to both sides, plus 3. So I would end up with 3 plus and minus 1 over root 2. Now, I have no idea where that goes on the graph, so I'm going to have to stop and I'm going to have to break out my calculator. And essentially what I'm going to do with the calculator is I'm going to do two equations here. I'm going to do x equals 3 plus 1 over root 2. So we'll find out what that equals. And I'm going to do x equals 3 minus 1 over root 2, and we'll see where that ends up. All right? So give me a second here. So this guy is 3.7, and then let me do the other one here.
Charles Madeira, please come up.
This guy turns out to be 2.3. So we've got two x-intercepts, one at 3.7, so over here on this side. One of them at 2.3 over here on this side. So the left side of my graph is pretty obvious. I can just roll right up here. The left side, if you understand what's going on here, all you got to do is roll the right side down. If you understand the left side, then you understand the right side. You'll notice both sides are going up in this case. The reason they're doing that is because the equation has the squared part underneath here. So both sides are going to be going the same direction. All right? Domain really quick here. Domain, x in the set of reals. X cannot equal the vertical asymptote at 3. Range, y in the set of reals. Y cannot equal, oh no, excuse me, my graph is above the horizontal asymptote. I need to slow down here. My y values are all above -2, so my range would be y greater than -2. Or you could say -2 with a parenthesis, comma infinity with a parenthesis, and you're done. All right? Okay, we'll do a lot more of these.